Hello to the team. Myself, Pranav Parekh, along with my engineering team, coupled by Mr. Aniket Raul and Mr. Grunit Panchal. We are a team of 3 engineers working on the current project, how to reduce the fatal injuries or fatal accidents in a roller coaster ride. For this project, we have taken a lot of past incidents from 2003 Disney Wonderland, and some of the roller coaster incidents happened from Japan. And we are going to present some of the faulty analysis based on our research and analysis. Yes, next slide. In this ongoing presentation, I, Pranav, is going to put some of the introductory notes up, along with a little sense on our two faulty analysis. So yes, as I have said previously, there were a number of fatal injuries happened in past when where a lot of customers were riding on the roller coaster, and a sudden accident, a sudden failure in mechanical system, a sudden failure in lockdown mechanism, and a sudden failure in passenger ejection seat happened, and that costed a lot. And in future, to reduce this sort of to reduce this sort of, I would say, injuries or accidents, we have considered two major factors out of our research and analysis uh, report. The two major factors that we have considered are one is the passenger ejection seat, sudden ejection seat, and the second is the sudden derail of the cart from the track. Next. Considering the first fact, there are two, as I have said earlier, there are two there are two faulty analysis that we have constructed by far, and one is going to be presented by, or I would say one is going to be denoted by a particular engineer, and the later one would be denoted by the later engineer. Yes, so from here, the team would continue.
Thank you so much, Pranav. Now from here, um I will explain about fault tree uh, on how car derail from cart. So here is the fault tree which we have prepared for car derail. Here in this case, um, while doing fault tree analysis, we can clearly see that uh, it is occurred due to two main reasons: destructive construction and control system breakdown. Further, when we dig into destructive construction causes, we got four main problems which are created: uh, incorrect design, poor quality building of track, low quality material used, and improper alignment of track. Uh, in poor quality building, we got two main reasons, which are improper angle and welding problems. Welding problems were caused mainly due to unskilled labor and welding machine fault. On the other hand, control system breakdown is also considered an important role for derailing the car from tracks. Electrical part dead and incorrect data entry can be responsible for this problem. In addition, lack of data, wrong formatting, unskilled employee, and no standard formatting for data entry are the responsible reasons for causing this type of problems. Here, we have also done a qualitative and quantitative analysis. So, let's talk about qualitative analysis first. Qualitative analysis is used to identify critical events, potential system weaknesses, and best way to reduce the risk associated with the top event. Here I have calculated T equals to G1 plus G2. Then T equals to G3 plus G4 plus G5 plus G6 uh, plus G7 plus G8. Um, now, at last, T equals to G3 plus G9 plus G13 plus G14 plus G5 plus G6 plus G7 plus G11 plus G15 and plus G16. This is the minimal cut set for derailing of car from track. Now moving forward to quantitative analysis. Quantitative analysis is used to calculate the probability of occurrence of the top events, giving the fault tree and probability of occurrence of the basic events. So now let us consider the value of G3, G5, G6, G11 and G13, uh, which is 0.0001 and G7 equals to 0.01, and last but not the least, G9, G14, G15, G16 is equal to 0.001. So let's calculate in a mathematical way here. T equals to G3, G9, G13, G14 plus G5 plus G6 plus G7 plus G11 plus G15 plus G16. So in total, we will get a number of 0.0145, that is 0.015. So now I would like to invite my dear friend Aniket to continue this presentation, and he will explain the reasons which are the action which are recommendation. So Aniket, please continue the PPT.
Thank you, Krunit. As we can see, the both analyses were explained, and it was pretty much clear that quantitative analysis would be more preferred over qualitative analysis, as it is more scientific, objective focused, and it's more acceptable. Whereas qualitative analysis is used when the researcher has no idea what to expect. Uh, for the recommendation would be like using qualitative analysis as complementary methods, which with a combination of both, so that we can get both wide-reaching and deep results. Simply put, quantitative data gets us numbers to prove the broad general points are correct, and the qualitative analysis brings us the details and the depth to understand the full implications. So, like qualitative analysis can be used to gather detailed information of a topic. We can say it for like formulating the hypothesis, and quantitative analysis gives us the numbers which can be used for statistical analysis in order to validate our hypothesis. So yeah, like both of them can be used in the combination to get better results. Other recommendations would be, if we see at the fault tree analysis, proper data entry forms should be carried out, so that each and every detail of the event is correctly mentioned in those forms, and that can be used and back tested to formulate new methods or strategies to perform the ride safely and smooth for the passengers. The passenger seat mechanism can be improved, like more safety belts or more safety related mechanisms can be introduced. The auditing and regular maintenance of the rail tracks or the car should be conducted and should not be neglected at any cost, because if an error occurs, it could cost us a life. So also, well-skilled and trained operators should be appointed to run and operate the roller coaster system as a whole. Yeah, those would be the recommendations we could come up with, and yes, this could be good from. Thank you.